Good morning, everyone. Today I'm going to present on data centers. What is a data center? How data center works, and how does it looks like? So basically, a data center is the infrastructure behind many of the digital services we use every day, such as cloud applications, online banking, and social media streaming platforms such as YouTube, Twitch, and many other Netflix and also AI. So in this presentation, I will cover the major components of data center, how they operate, their security and sustainability, and finally how AI is changing the industry. So moving forward to the next slide. Before going into the individual chapters, this slide gives us a basic picture of data center. Okay, so there are several systems working together. First one is compute, means the server that process application and request, storage which keeps the data, networking allows data to move uh, between server and users. Power keeps all the equipment running, cooling remove the heat generated by the IT equipment, and finally security protects both the physical infrastructure and the data. So a data center is not simply a room full of servers. All this system has to work together to provide continuous services. Okay, now as per the first chapter, it would be data center, one introduction to data center. As I have told you at the beginning, a data center is a specialized facility which to house the IT equipment. Means the main equipment that includes in the data centers are server, storage, and networking device. But supporting that data center infrastructures, that would be power, cooling system, security, and fire protection. These are equally important for data centers. So data center, inside the data center IT equipment are also equally important, as well as the whole building is also equally important. So that is the reason we power is also important for the data centers, security and fire protection. So data center have also evolved significantly. Was from before times in 1950s, if you find around large mainframe systems were used, very big systems were used were used to store the data. And now then from there a dedicated computers room came, then internet, then cloud data centers were introduced. Now we are moving toward highly optimized AI infrastructure. So today data center also support almost every major digital industries, including finance industry, healthcare industries, communication industry, entertainment industry, and e-commerce industry. Some important terms also we should know that are uptime, redundancy, latency, bandwidth, and PUE. So what is PUE means? Power usage effectiveness, means it helps us to know how much the infrastructure is taking the electricity, or what we say that just to compare, is the facility is in a good condition, is it healthy, it is not healthy, is there any problem. That's the reason we use PUE. If there is a formula for that, it would be like total power consumed by the facility and divided by actual power used by the IT equipments like server, storage, and networking. These are the IT equipment. Storage is the main, I mean the server is the main IT equipment over there. All the storage and networking are inside the server. So how much they use electricity at top divided by total number of facility has been used. So divide those things, you will get the answer. Now moving to the next topic, which will be data center types and their tiers. So data centers can be classified based on how they are used. The first data center would be enterprise data center. This data center is generally operated by their organization for its own requirement. So some big organization create their own data center, build their own data center, and work on them. They don't require rented space. Okay, but next moving forward to the second data center would be called as co-location data centers. So co-location data centers allow multiple companies to rent space and infrastructure. Means if I have a building, I have four floors. On four different floors there are four different data center owned by the four different companies. So co-location means allowing four different peoples to own the floor to run their own data center. Okay, now coming to the third data center, which is known as hyperscale data center. Because what is hyperscale data center? Hyperscale data centers are the data center which operates at a very, very large scale. They are generally associated with the major companies, cloud companies, not normal companies, the cloud companies that are known as, AWS, Amazon Web Services, uh, Microsoft Azure, Google, Meta, Apple. These are the big major cloud technology companies. So they uses hyperscale infrastructure or data center for their own use. Now coming to the edge data center, that will be the last data center. These data centers will be located near to the user to reduce the latency. Means if there is a longer latency, the transfer of data will be very less, not that speed. But if the data center is located near the user, if I am standing here and my data center is over here, I will get fast network. My information will be forwarded very fast, and it will travel at very fast speed. Now we also classify these types of data centers in from using tier 1 to tier 4. If you can see in the image over here, we can also classify it from tier 1 to tier 4. The level of redundant from so we if we move from tier 1 toward tier 4, the level of redundancy and availability increases. But in tier 3 is designed for concurrent maintenance, while tier 4 provide fault tolerance. If there is any fault, tier 4 level of equipment handle their own fault. So basic difference is this the type tell us how data center is used, while the tier tell us how reliable and redundant the data centers are. Okay. Now moving to the next topic, it would be physical infrastructure. So what is the physical infrastructure? Now let's look at it. The physical infrastructure means the first important decision is choosing the location to build the data center. If you see in the image over here, you can see there are building pipes going on, some racks are there, a cooling system. This is a flooring. This is the physical infrastructure of data center. To build that data center, the first important decision is choosing the location, because we need sufficient power, suitable land, good network connectivity, and protection from environmental risk. Environmental risk like typhoon, hurricanes, cyclones, and what we say that floods, these types of environmental risk. We have to select a good location, good piece of land, and area which have good connectivity. And inside the facility, and once we get the area, good land and all, we will build that facility, build the infrastructure, and inside that infrastructure racks are used to install the we install rack means server racks, where we keep our servers. It is a stack of racks. If you find a shelf in your home, it's just like that. So racks are used. So racks are commonly measured in one unit, u as a u. So one unit is around 1.75 inches. So basically this separation, this type of we use these types of inches to measure the spaces, how much it require, how much a server will take a place. And we also use what we said that hot servers also, we use hot and cold aisles. The front of the server receive cool air, the back of the server release the hot air. So this separation improve cooling efficiently. Fire protection is also important, because conventional water based systems can damage, not cannot, but can damage the system. So we use specialized water, which is a non-conductive electrical water. So if we pour it directly on the server, it won't conduct, because there won't be an electricity passing of electricity in that water. So we also use specialized fire suppression and early smoke detection system to know if there is a little bit of smoke coming from any of the server. Automatically the fire alarm will ring and we will know the fault where it is happening. Okay. Now coming to the third topic, what is fourth topic? Now the third one, sorry, it would be power system. So power is one of the most critical system in a data center, because electricity is required to run a data center, because we are running data center 24 hours a day, 7 days a week, 365 days continuously we are running. So power is the most critical system in the data center. So that let me show you the basic power path. Show this is the utility. From this utility you will receive the electricity. It will be transferred to the transformer. What will transformer would do? It will convert the electricity in voltage, and the voltage will be passed to the switch gear. With switch gear means it is kept, or it will be on the top of the racks of the servers, which will help us to, once we turn on, it will segregate and aggregate the functions and make sure the electricity is being distributed to UPS. UPS means uninterruptible. It doesn't go to UPS, but it goes to PDU. UPS is uninterruptible power supply. It is basically a backup generator. So we usually keep it. For example, if there is no electricity coming from the electricity department, or there is any fault in going on in electricity department, and they said that it required 24 hours to repair their department, so we use UPS technology, which is known as backup generators on uninterruptible power supply. So what they do, they give us backup energy. We store the energy, we fill diesel, put diesel or petrol inside it, and we get an electricity. PDU is power distributing unit, which distribute the power to the racks, which I have showed you in the infrastructure before. In the infrastructure, in the third topic, you see an infrastructure where you see the servers. There, the PDU will distribute electricity to each and every server in that. Okay, so uh, and the main objective is to make sure that a power failure does not immediately bring down the IT equipment. So in simple term, if I tell you, the utility is the primary source. The UPS handles the immediate interruption, and generator provide longer term backup. That's all. And now moving to the cooling and thermal management. So server generates a lot of heat while operating. So cooling is also essential. For example, if this is my phone, and if I'm running this device 24/7, 24 hours a day, will this heat up or not? It will heat up. Just for it to him cool down, I need to keep my phone aside on a table or under a fan or some refrigerator if possible. Just kidding. So just my phone to cool down so that I can use it afterwards. So now, but for like even if we are sleeping as well, we just keep our phone on the charging and we'll sleep, because it will be at that time, it will be a rest period. But for the server it is very much different, because server runs 24 hours a day, 7 days a week, and 365 days it will run continuously. So server generates a lot of heat while operating, so cooling is essential. But before that, traditional cooling were used. Traditional data centers, we use in the older data centers, uses air-based conditioner, like air conditioner, ACs, which we have on our home. In that, in very old days, in traditional data center, way back, they uses AC systems like cassette AC just to cool it down. But as the server density increases, their requirement increases, AI came into the picture. So what AI use? AI does not use CPU. It uses GPU, graphic processing unit. So that cooling system, air cooling system, is air conditioner, AC system was not very effective for that. So what we are using toward them, we are using liquid cooling system, which is liquid is a form of it is a non-conductive water, which I told you. If we put it on the server or any processor which is running 24/7 or 24 hours a day, 7 days a week, it's just like water. Liquid can transfer heat much more efficient than air. If I heat a piece of metal and keep it outside, it will take 2, 3, 4, 5, 6 hours just to cool down. But what if I take that heated metal part, and dip it inside the water? It will take hardly 10 to 15 minutes to cool it down. So because what's happening, if you are putting that piece of metal inside the water, first the air is pushing out, you will see smokes coming out. That's why the heat is getting transferred, right? That's how it is cooling down. So there are different approaches as well for cooling system, like rear door heat exchanger, direct liquid cooling system. Immersion cooling system is something. Immersion means dipping all our server inside the non-conductive water. Okay, so and the major trend here is a traditional room level air cooling are more target towards liquid for high density equipment. So traditional is used for traditional cooling system is used for the traditional use only. But now, as we are moving toward a very big systems like AI is coming, it required more power, more thing. So we targeting liquid cooling system for high density equipment. Now moving forward to the connectivity. So networking is very much important in our life. Without network, we cannot transfer a message, we cannot put a message to anyone else. Okay. So networking is responsible for moving data within and outside the data center. Okay. Without networking, no data can be transferred, no data can travel somewhere. So the network then move also network then move towards aggregation and core infrastructure, and we commonly use some switches called as top of the rack switches, TORS, top of rack switches. These switches are commonly used to connect the server switches, and once we turn that on, the network will move towards aggregation and core infrastructure. And so the modern data center, it was on the older days, but now in the modern data centers often we use leaf spine architecture, which provide high bandwidth and predictable connectivity. As you can see in the image over here, this is a leaf spine architect. It is providing high bandwidth and predictable connectivity. Network speed is also been increased from like 100G to 400G, 800G, and there are different types of technology came. But this also especially become important for AI because large number of GPU also needs to communicate with each other very quickly. So faster network is also required for that. Now going to the storage and computing part. Now we have two important areas. Okay, two important areas. That is, one is compute, another one is storage. So basically, compute is where processing happens, either to processing request and application. So compute is where processing happens. So CPU are generally used in this. They are generally purpose, while GPU are highly suited for parallel workload such as AI. And modern data center also uses specialized processors such as TPU and other AI accelerator. On the other side, if we search for storage side, if we go, we have HDD, SSD, NVMe storage. There are mostly we will find it inside a PC, and HDD are the most generally used with high capacity, and they are cost efficient and more important, while SSD and NVMe might provide much more performance. They are both equal to each other, but SSD and NVMe provide much higher performance. Okay. Now, if we move forward, we also have SAN, NAS. These are the type of object storage with different application requirement. So if we simply put it, compute process the data while storage keeps the data. Just keep this in mind. Compute process the data while storage keeps the data. Now, moving to the security, which is also a major thing in data centers. And like security in a data center has two major sides, like physical security and cyber security. So physical security protects the actual facility, means my building, it will protect my building. How they protect? They use CCTV, access card, biometric authentication, security personnel, and controlled controlled areas where we at time to time the guards shift changes. Okay. And cyber security protects data infrastructure while using firewall, intrusion detection, encryption, identity theft, identity management. So one of the most important privilege is principle in a data center is least privilege. We have to give least privileges to the persons who are we are handling the data center, handling the data center. So each and specific person should have their own specific least privilege so that they can perform their jobs. So security team also continuously monitor the infrastructure and investigate suspicious activity. So security is not a single system. It is layered approach like perimeter, access control, CCTV monitoring, RAG data. These are the types independent security layers, and this is a layered approach. Okay. Now moving to the next topic, it would be operation and management. How a data center is being operated, how it is being managed. So a data center needs to operate continuously. As you know, power supply needs to be there. It needs to be operate continuously so that good flow of work. So proper management is also extremely important in this. So different teams are responsible for different areas. Facility engineers, there are different teams which are responsible for the different area, different specific area, different job specific area. So facility engineer handle power and cooling system. He is the one who handles the power and cooling system. And when it comes to the network engineer, he manage the connectivity between the server is going good or not. And system administrator manage server. Means system administrator are the person who manages the server and operating system, if the server is working good or not, if the operation is working correct or not. And the security teams are the person who manages the monitors the threat, like cyber threat, hacker threat. They're all the, and there are also two types are NOC and field technician. These are for monitoring and physical support. If for example, if one of my server rack, a specific server is not working, so a field technician will go there and change the server. Another important technologies also came into light, where DCIM means data center infrastructure management, which also give, this is a type of management which give operator visibilities into things such as power, cooling, space, and equipment. So this to make sure that sorry, and so that mistakes can be caused, this doesn't cause a major outrage. So DCIM are the persons who make sure that doesn't check the facility and make sure that doesn't there is no major outage. Okay, change management also are the person who reduces the outage risk, means current outage risk. They are the person who will look into that. Now moving to the next topic, how a data center can be a sustainable and a green data center. So data centers consume large So sustainability and green data centers, so basically some cooling system also consume waters, and like data centers consume very significant amount of electricity, so it also use much more water. Because of this, sustainability has become an important part of a data center design. Operator are using renewable energy through methods such as solar, wind, power purchase agreements. This is the type of way we can sustain a green data center without harming the environment. So another important concept which was came to like about 24/7 carbon free energy, where the objective is to match electricity consumption with carbon free energy continuously. So rather than only on annual basis, but monthly basis, if we take a talk it about. So a green data center is not only about renewable energy, it is about reducing energy, water, and material waste. Okay, now if we move toward the economics, finance, and investment of data centers, so data center requires very large investment. So and we gradually divide because building a data center is a very big amount. We need a space, we need to buy a land, build the building, hire the laborers, and there are different types, there are many ways to do that. So but we generally in IT world we divide this into two types. One is capex, one is opex. Now first we will go with capex. Capex means, the full form is capital expenditure. Capital expenditure. So this money is basically the money we spend to build the facility and install infrastructure, to build like bricks, cement, walling, everything which come into capital expenditure. This is the thing we spend to build a infrastructure. Now if we move forward to the OPEX, OPEX means operational expenditure, such as power running, electricity, maintenance, employees, security, and other connectivity issues. This comes into operational expenditure, means something running inside the infrastructure which is costing us. It is also an expenditure, right? We are paying for the electricity, we are paying the employees to make sure there is no cyber threat on our data center, we are paying the security persons to make sure that they look out for the facility. And also data centers can generate revenue through co-location as I told you, and also cloud services are also being used, because electricity is one of the major important and very much of the major important and major operating cost of the data center, because utilization of power and capacity utilization have their own impact on that, because because the economic of the data centers runs One we how we earn only the electric once the electricity is there and the data center is working, then only there is an economic, there's an economy, there is a finance, there is an investment through in the data center. Without those things, the data center won't work. We won't, in the first place, we don't even able to build the data center without finance. Okay, now moving to the 12th chapter, it would be hyperscale and major players. Who are the hyperscale data center and who are the major players of these data center? Who owns these data centers? So if we look at these major players, the major companies, if we tell major people who have the hyperscale data center, those industries are known as AWS. AWS is Amazon Web Services, which uses hyperscale in data center, Microsoft Azure, Google Cloud, and Meta. These are operate at infrastructure, these operate infrastructure at extremely large scale. So these companies are commonly associated with hyperscale infrastructure because they just don't buy standard equipment, not just cheap equipment. They buy high, increasingly developed customized processors, server networking system, and cooling solution to improve efficiency and performance. Because if they don't increase, they don't buy highly priced good equipment, then they will at very big loss because there are many billions of customers been connected with them. But and if we come apart from hyperscalers, also there are also major co-location provider, means the persons who provide a data center space, that are Equinix and Digital Realty. These two are the other companies who they provide data center spaces like hyperscale space as well as normal just a floor space just for the company. So these companies, as I told you, these companies provide infrastructure to the other organization so that they can use it and rent it. Okay, now coming to the emerging technologies, how data centers, how there are other technologies have been emerging in today's world. So data center is a technology, and a technology is continuously evolving. So data center technology is continuously evolving. So one area is quantum computing, which uses a complete different computing principle and requires specialized information, because this specific computing is very high intelligence computing. It's been used by the system is very highly developed. It's not working on cheap things, it is used very pricey equipment to run, because it requires a specialized environment. Without those specialized environment and without that specific principle, the computer won't work. If it works, it will get heat too fast, it will get heat up very fast. And now there is another thing also known as photonic, or we can call it a optical networking, where we use light concept. Light travels faster than human, faster than anything. Light speed, you have heard about this term. So photonic or optical networking, both are same. Optical networking is something which we use light, is used to move data at extremely high speed. So we use light concept to move data at extremely high speed. We also have neuromorphic computing, which what is neuromorphic computing means, it take inspiration from the way the brain process information, how our human brain process the information. It takes an inspiration, mean that specific system takes an inspiration. The person who built that specific neuromorphic computing, the person who built it, he took an inspiration from how a human thinks, and he wants to make sure that create a robot or create a computer system who works exactly like a human brain. And computational storages move some processing or closer to the storage device as well. So these are the basic things if you think look into it. Now moving forward to the digital data centers, means data centers today in AI era, means as you know, AI is booming. There are many AI came to world like Groks, ChatGPT, Gemini, Perplexity. There are different type of data, what we say, AI models. But artificial intelligence is one of the biggest factors changing modern data centers. And AI requires, because AI requires huge amount of computing power, because it requires a huge amount of computing power because it is an AI. And especially that huge amount of computing power is usually used by GPU. GPU means graphic processing unit. So these there are two major AI workload. Means how AI handles the workload and what are the workloads which are used in AI. One is training and one is inference. So training means building the model by processing very large data set. Well, I am building an AI. So to have an AI to work, we need to add in information in it, right? To process very large information or large data set. Inference means using the trained model to generate prediction or response. Means if I already have a trained AI and using that specific trained AI to train the other AI to help us how it is working, how it is generating a prediction, and how the response is coming to the customers. Okay, because AI also creates a major challenges in this world. If we go AI, if whatever we are doing AI, we required AI in everywhere. Now, finally, we will look at the future of data centers. What is the future of data centers? So one of the biggest trend is AI first data centers, because these are designed specifically for high density GPU workloads. Liquid cooling system will also become increasingly important. Power availability is also becoming a major challenge because AI is increasing electricity. Okay, running an AI facility, AI data center, it required a huge number, a large supply of electricity just to run it. Because AI is increasing its demand for electricity demand. So, but in near future, whatever the person's thought, like technology need to they are trying to work on technologies such as nuclear power, small modular reactor. This is also a potential source of reliable large source of electricity. They are just exploring that idea. They're trying to build a small nuclear power or small modular reactor just to make sure that it provide efficiently electricity. And we are going to see in the near future, we are able to see edge computing, where processing happens closer to the user and device. At the same time, technologies also such as optical networking, as I have told you, memory pooling, quantum computing, new storage technologies will also be developed in near coming future. So basically, the future data centers uh, uh, will be designed around the availability of the power, because the density of computing and efficiency of cooling is also required. Without this thing, there is no data centers for AI, because we required those all these things. Now coming to the last and the end of the topic, it would be how shall I conclude this? Okay, so to conclude this, I will just tell you what happened from the start till end. So to conclude this, data center is much more than a collective or collection of servers. So we need to compute process information, like we need compute, like we need a compute to process information, storage to keep it, networking to move it. We also need power to operate the equipment, cooling to remove the heat. We need security to protect infrastructure, and operation to keep everything running continuously. And as AI grows, power density, liquid cooling, high speed networking, and sustainability will be becoming even more important. So, the overall idea, if I put it in a simple term, is compute, storage, networking, power, cooling, security, operation is equal to data center. Thank you.